all. So this is a video that's giving you a little bit of a reminder about some of the review material for this course. So we're going to go over quite a few things involving how fractions work, how we cancel things, and those kinds of things. So I just want to go through and simplify some expressions for you. The first one is this one. So if you have an AB plus AC all over A. So what we want to notice here is that there is an A in each of these three terms. And so that means that what I'm allowed to do here, and we're going to get into this in detail, but when they both have an A, I'm allowed to factor that A out. So I'm going to bring that A in the numerator out to the side. And that leaves me with B plus C when I pull it out as a common factor. And then that's all over A. And this is then really B plus C times A over A. And I can regroup them like that. I'm allowed to pull my fractions apart and put them back together because really this is over 1, right? And I don't even have to write that, but it's understood to be that. So if I were to multiply those two fractions together, I would end up right back where I started because we multiply across with our fractions. And then this piece right here is A divided by A, and that's equal to 1. So this would become B plus C times 1, and the 1 then we don't need to write. So this is just B plus C. And what that allows us to do is it allows us to simplify fractions where we have something in each term. So essentially, as long as you have an A in every single term in the numerator and every term in the denominator, I can cancel it in both places, okay? And that's what I want you to see here. With fractions, when we have something like B plus C divided by A, what I can do to simplify this one is I can split it up, okay? Because B plus C are two terms and they both have A as that denominator, so I can kind of divide through by A and make it B divided by A plus C divided by A. Okay, that's a funky looking A. Let's try it again. There we go. Okay. And so you can pull your fractions apart. And this comes back to the idea that if you're adding two fractions, when we add two fractions, first they have to have a common denominator. They both have A as their denominator. And when we add them, we add numerators and keep the denominators. So that's what we did when you see the left-hand side there. Okay. So we can split up or add back together. For number 3, when you see two things that look the same, but they're in the wrong order, if it's addition, they just cancel. That's exactly the same thing because addition is commutative, right? But these are subtraction, so order does matter when it comes to subtraction. So what I can do here is I can leave the numerator the way it is. And what I'm going to do is I'm going to factor out a negative from the bottom. So I'm going to factor out a -1, right? Or just a negative. You can get rid of the 1 if you like. So if I have B, so I'm looking at this term, and I pull out a -1. So I need to put something in this spot so that -1 times this number gives me B. So I'm going to make it negative B. That way, -1 times negative B is positive B. And then for the minus A, I'm going to pull that negative out front. So then it's going to become positive A, right? And that way we can check to see if you distribute your -1 into here and here, that's going to get you the B minus A, right? Keep in mind that plus a negative and subtraction are interchangeable. Those are two exactly the same things, right? Because we know that when we subtract, that's the same as adding the opposite. So you'll see me switch back and forth between add the negative and subtraction signs regularly, okay? Now, what I can do next with this is I've still got my A minus B on the top. Now I've got my -1 out front. Now, what's inside here is addition. And addition, I'm allowed to switch the order and it doesn't matter. So this is still A plus -B then, right? Switch the A and the -B. And then, as I mentioned before, I like to switch back and forth pretty regularly between subtraction and addition of the opposite. So this is the same as A minus B on the bottom in parentheses. And then I've got two of the same exact thing, top and bottom, and I'm allowed to go ahead and cancel those two things. And so that means this is going to actually turn into 1 over -1, and 1 divided by -1 is just -1. So after all that, I end up with -1, okay? So essentially, two things that are being subtracted in the opposite orders. When you divide them through, you get -1, okay? And it doesn't matter which one's on top and which one's on the bottom, okay? All right, let's talk about number 4. We have A divided by B divided by C. Okay, so I'm going to rewrite this a little bit. I'm going to make this one like a fraction bar. So that's going to give me A divided by B over C. And then I'm going to rewrite the top one as a fraction bar as well. So that's A divided by B, all divided by C. Okay. And now our rules for complex fractions, anytime you have a fraction divided by another fraction, what we do is we keep the first fraction, the top one, so that one stays, right? So this fraction stays. And then it says divide by, so I'm going to write it as divide by C, right? And I could have gone this way the other right away. And then C is really not C, but C over 1, because we're thinking about it as a fraction, because A over B is a fraction. And then in order to divide two fractions, we're going to multiply by the reciprocal. So we're going to keep that A over B. We're going to change it to multiplication, and we're going to flip the C over 1. So this will become 1 over C. And then when we multiply across, A times 1 is A, and B times C is BC. So what we end up with is something that says that A divided by B divided by C is really A divided by BC. Okay, A is being divided by both things. And then lastly, don't forget that when we're working with the opposite of A plus B, that we need to make sure that even though there's not a number sitting here, it's just a sign, that is understood to be a -1 outside of parentheses. And we need to make sure that that negative gets distributed to both terms. So our distributive property says -1 times A is -A, and -1 times B is -B. Okay, and again, I'm likely going to switch that and make it -A minus B, just so that I can write less stuff. Okay, and so that's what I end up with here. All right, well, next we're going to get into some exponent rules. We want to make sure that we have these down. Anytime you're working with exponents and you have two powers that have the same base and they're being multiplied together, we're going to add exponents. So multiplication of two things becomes adding exponents. So this is x to the m plus m. Okay. So for example, if you had x squared times x cubed, you would make that x to the 2 plus 3, which would be x to the 5th. Okay. For division, instead of it adding, we subtract. So this is x to the n minus m. So if we have x to the 4th over x squared, this becomes x to the 4 minus 2, or x squared. When we have powers to powers, and note the difference between 1 and 3. 1 is multiplying two things with the same base, and number 3 is taking a power to a new power. In this case, we're going to multiply n times m. Okay, so if you have x squared to the 3rd power, you're going to take x to the 2 times 3 and get x to the 6th. All right, now on to the trickier ones. So x to the -n, anytime you see a negative exponent, that just tells you that it's in the wrong part of the fraction. So if we think about this as a fraction of being over 1, that means that that's in the wrong part of the fraction. So I'm going to move it to the bottom. So x will now become a positive n, right? When you move it, you change the sign. And now we hold the top spot with a 1. Okay, so essentially we flip the fraction. So for example, if you had x to the -3, that's going to become 1 over x cubed. Square roots are pretty common in this course, and those are going to translate as x to the 1/2 power. Okay, so fractional exponents mean that you have roots, okay, square roots, cube roots, something like that. And then in general, if you have a different kind of root, an nth root, and your x has a power of m, this becomes x to the m over n. Okay, so for example, if you have the cube root of x, now instead of it being a 1 over 2, it's a 1 over 3, so x to the 1/3. If you have a 4th root of x cubed, this becomes an x to the power on the x goes in the numerator, so the 3 is up top, and the root is at the bottom, so this is 4th, x to the, oh, sorry about that. What just happened? I'm sorry about that. Don't know what just happened. There it is. It's back. Okay. There it is. So we get x to the 3 over 4. Okay. So those are our fractional exponents. So whole numbers, fractions, and negatives. So how do we then simplify some expressions? So we're multiplying two expressions. We're going to go ahead and kind of match up the things that are the same. So I'm going to look at the number part first. So I've got 1/2 times 16, and 1/2 times 16 is going to be 8. And then next I'm going to look at the power of terms that have the same base. So x to the 4th and x to the 5th have the same base. When you multiply them, we add exponents. So this will become x to the 4 plus 5 gives us 9. So this is going to give me 8x to the 9th. On to number 2. Oh, let's see what's going on here. So the first thing I notice, I'm actually going to skip that first fraction, and I'm going to jump over here, and I have something in parentheses to the 0 power. That's not something we talked about, but we can jot it down. So if we go back up here to our rules, one of the things that we could add is that x to the 0, anything to the 0 power is 1, okay? Rule number 7. So that means that everything you see here is being raised to the 0 power, which means that whole piece is going to be 1, okay? So now I just have to figure out what's going on over here. Now, when you have more than one thing going on inside the parentheses and it has a power outside, you have to distribute that to each piece. So I have to square the 6 and I have to square this part. Well, if we square 6, that's going to give us 36. And now I'm taking powers to powers. So I'm going to take x to the 3 times 2, and that's going to give me x to the 6th. On the bottom, same kind of thing. So this 3 has to get applied to the 2 and to the x squared. So if we take 2 cubed, that's going to be 8. And x squared cubed is going to be 2 times 3 gives me x to the 6th. Okay. Now, let's see what's going on next. So next, to simplify this part, we want to simplify the number part. So now we're focusing in on the 36 over 8. That doesn't divide evenly, right? But they both have factors of 4 in there, right? So 4 goes into 36 9 times, so I get a 9 up top. And 4 goes into 8 twice, so I can reduce it to 9 over 2. With the x to the 6th, we're going to dividing here so we can subtract. So this is the x to the 6th minus 6th, and that turns out to be 9/2 times x to the 0, and x to the 0 is 1, so that becomes 9/2. The other way that you can think about it is that those are the same term happening in the top and the bottom, so I can just cancel them out. And I end up with just 9 over 2. Okay, next. All right, now we've got exponents going on and square roots and all kinds of things. But we're not going to worry too much about it at first. We're going to use the same rules that we've been doing. So we're going to apply this -1/2 is being applied to everything in the parentheses. So I want to apply a -1/2 power to everything. So if I do that to the top, then I'm taking x to the 6th to the -1/2 power. So I'm going to multiply my powers, and 6 times -1/2 is going to give me -3. On the bottom, I'm taking 16 to the -1/2 power. So 16 to the -1/2 power. Then I'm taking y to the -4th to the -1/2 power, and that means I'm going to multiply those two exponents, and I'm going to have y, and 4 times 1/2, well, -4 times -1/2 gives me a +2. So now I've taken care of that piece. The next thing I'm going to do is take care of my negative exponents. So again, a negative exponent means that it's in the wrong part of the fraction. If I want to make it positive, I have to move it. So this x to the -3 is currently in the numerator, and its exponent is negative. To get rid of that, I'm going to move it downstairs to the denominator and make it positive. Same thing with the 16 to the -1/2, only it's starting in the bottom, so to get rid of the negative, I have to move it to the top. So this becomes 16 to the +1/2 power. The y squared is good to go, so I'm going to leave it there. Okay. And then the last thing is that we have to deal with the 16 to the 1/2 power. And 1/2 power, if you remember from above, means square root. So this is the square root of 16 over x cubed y squared. And the square root of 16 is 4. So this becomes 4 over x cubed y squared. Okay. On to number 4. Same thing here. We're going to apply this 3/2 power to everything in the parentheses. So for our c in the numerator, we're going to take -4 times 3/4, and that's going to give us -3. we're going to have an 81 to the 3/4 power. And our d, we're going to multiply that 8 by the 3/2. 8 times 3/2 gives us 6. Okay, now the only negative exponent I have is in the numerator, so that means that c is in the wrong spot. So I've got 81 to the 3/4. I'm going to move that c down. Now, keep in mind, we typically we do numbers first and then our letters in alphabetical order. So the c will come before the d, so it will be c cubed and then d to the 6th. Now, I don't have anything in the numerator, so I hold that spot with a 1. Okay. And then the last thing I need to do is I need to evaluate this part, the 81 to the 3/4. So I usually try to do the root part first, unless it doesn't work out for me. So the root part, and that's because I want to make the number smaller before I make it bigger. If I make it bigger first, then I'm going to have a harder time finding out what the 4th root is. So the 4th root of 81, the square root of 81 is 9, and 9 is the square root of 9 is 3. So that means that the 4th root of 81 is 3. So this is 1 over 3 cubed c cubed d to the 6th. Because all I did was take care of that bottom part of the fraction, this one right here. Just this 4 right there, right? I didn't mess with the 3, so the 3 is still there. Right? And that's because this becomes 81 cubed to the 4th root. Now, you don't have to do it in that order. The order that I do it in is actually this. So we're going to take 81, the 4th root, and then we're going to cube it. Okay? The order in which you take those powers doesn't necessarily matter. And so this becomes now 3 with the cube on the outside. Okay? And then 3 cubed is 27. So this is 27 c cubed d to the 6th. All right, and that's going to do it for our exponents and sections 1.1 and 1.2. These are going to come up frequently throughout class, so continue to ask questions and make sure that you know what's going on, but you can always reference this video for the rules.